Hello everybody, welcome back. Last video just cut us off at the end, but this is where we got to here, where the x minus 1's cancel from the top and the bottom. And now we can check again. Can I just directly substitute the t value in for here? Oh, I need to change my limit though. X is going to 1. Okay, can I just plug in 1? I remember I couldn't before because that would have made a 0 in the denominator. We're not allowed to do that, so we did this rationalizing and it fixed it. So now, what happens if we plug in 1? I should get 1 on top, and then if x is 1 on the bottom, I get the square root of 1 plus 3 plus 2. Square root of 4 is 2 plus 2. And there you go. It's a really complicated problem, folks. But again, just remember your steps. Step 1. Try to directly substitute into the expression. What is the x value approaching? And try to plug it in. And if it doesn't work, step 2, we thought about maybe factoring and canceling, some kind of algebra magic. And then now step 3, if that doesn't work, now we have a new tool of, right up here, rationalizing the numerator. When you rationalize the numerator, you make it into a much simpler expression that you can directly substitute back in. All right. Let's end with one final thought here, friends. All right, well, look at g of x here. It's another piecewise function. It's very complicated. It's made up of 1, 2, 3, 4 separate functions. And I graphed it here on the bottom. I don't know if you remember how to graph these complicated piecewise, but that's a sort of a crude drawing of that function. Okay, using that, can we answer parts 1 through 4 here as part A? All right, ready for 1. Answer number 1. We need to find the limit of this green function as I approach 1 from the left-hand side, with 1 being the negative. So 1 from the left-hand side. If I'm looking at my graph, again, I'm not going to draw on there because I want to see if you can see it now. If I want to approach 1 from the left-hand side, 1 from the left, can you see that my y value approaches 1? For part 2, now I'm approaching 1, but it doesn't say plus or minus, so you do have to check both the left and the right. Remember, when there's no plus or minus on there, it assumes you need to check both. So we've already done the left. Left one is done, right? We said that was equal to 1. Let's check to the right of 1. As I approach x equals 1 from the right-hand side, approaching from the right, can you see that I get, actually, y equals, or the limit, equals 1? Well, good. That means the left is 1, the right is 1. So since the limits are equal, the limit for part 2 is 1. How about part 3? Part 3 is just asking, what is g of 1? Well, look at your graph. It's not the open circle, right? Because that's where it's not defined. But g of 1, the y value would be 3. Okay, and there's your first 3. All right, 4, 5, and 6. Do you want to give that a try? For part 4, you want to do x equals 2 from the left. For 5, 2 from the right. And then therefore use those two answers to figure out 6, 2 overall. Good luck. All right, folks, for 4, trying to figure out the limit of my function here in green as I approach 2 from the left. As I approach 2 from the left, it's going all the way to that dot, which is at y equals negative 2. All right, from the right-hand side for part 5, I'm approaching 2 from the right-hand side. So I take that last branch of my function here. As I approach 2 from the right, I'm getting really close to that open circle. So I'm getting infinitely closer to negative 1. So for part 6, they're asking overall, what is the limit as I approach 2 overall, which means from the left and the right. And are they equal? If you look at your answers here for 4 and 5, you can see they're not equal. So therefore, the limit does not exist. Has to be the same from the left and the right. Okay, great job on that if you understand it. But here's the point of it. Right up here, I've got this big blob in black. And this is your question. Did we need to do this? Can we figure this out without drawing it? Because honestly, if you see this on the AP test, do you have enough time to draw this? And we don't want to have to relearn how to draw these piecewise functions. So here's what I'm going to do. Let's do this whole thing over again, friends. What I'm going to do is I'm going to keep my answers on the right-hand side so you can see it. But let's just do this again without the sketch. And let me show you how easy this is. All right, here we go. Here's number 1 again. Now again, you know the answers on the right, but watch how we do it without the sketch. Here, we're trying to approach g of x as x goes to 1 from the left. Okay, now as x goes to 1 from the left, do you understand that to the left of 1 would be values less than 1? So look up here to your function, and which of these equations, 1, 2, 3, or 4, is where x is less than 1? Can you see? If you see it, it's equation number 1, right? Right here. This is where x is less than 1. Okay, well, let's do our first step, right? Whenever you see a limit, the first thing you try to do is plug it in. So let's plug our 1 in for x. And when you plug 1 in for x, you get 1. So the limit, as I approach 1 from the left, I just plugged it into that equation by direct substitution. Let's try the second one. Second one, again, I need to approach 1 from both sides. I did the left. Now I need to do the right really quick. So let me see. From the right, if I do the right, meaning 1 from the positive side, that means all values that are greater than 1. So again, go back up to the top, and where does it say x values that are greater than 1? And I'm looking around all the different inequalities, and I find it right there. Do you see it in equation number 3? That's where x values are greater than 1. So let's do, again, direct substitution. Let's plug 1 into our equation number 3. When you do that, you get 2 minus 1 squared, or 2 minus 1 is 1. Okay, so I know the limit from the right is 1, and we knew the limit from the left was 1, so therefore what's the overall limit? 1. So we use a combination of knowing which equation in our piecewise to look for, using the sort of inequalities on the right-hand side, and then just using direct substitution. Number 3 is just g of 1, and without the graph, we just look and see where is literally x equal to 1. If you look and see which equation is x equal to 1, I see it right here. And when x is equal to 1, what's your y value? 3. Take a break for a second and look at the right-hand side. Yep, same, same. Cool. Okay, let's keep going. How about 4, 5, and 6? Let's see if you can figure it out using just the equations. Here's number 4. Can you figure out, as I approach 2 from the left-hand side, where is it less than 2? Which equation uses less than 2? And here it is again. Equation 3 is where it's less than 2. So direct substitution, plug your 2 into here, and you get 2 minus 2 squared. 2 minus 4 is negative 2. All right, for 5. I want 2 from the positive side, so look and see which equation talks about positive 2 to the right of 2, meaning greater than 2. And if you look up here on top, the equation that is to the right of 2 is equation 4 here. So again, it's directly substituted in 2. 2 minus 3 is minus 1. And for part 6, that's easy. You just need to check and see, does the left limit equal the right limit? And you see here that negative 2 does not equal negative 1, so they don't equal. Therefore, your limit answer does not exist. And let's check our answers. For 4 is negative 2. 5, we got negative 1, and 6 is D and E. So do we need to sketch this? Actually, no, we don't, which is good news because it takes a lot of time. You can just do it by looking at the different places where you approach the x values and figure out which equation do you plug it into. And that's the end of the lesson. Great job, everybody.